Hi everyone, myself Siddharth Jain. I'm a software engineer at Velotio Technology. So in today's video, we're going to learn about bringing AI to the browser. Yes, browser. So AI has been linked with many languages like Python, Rust, Golang, etc. But it's not with JavaScript. So today we're going to connect compatibility of JavaScript to the power of AI together in a library called Brain.JS. So let's learn bringing AI to the browser or exploring neural networks with JavaScript. So what is the agenda today? So we are going to learn what are neural networks, what are different types of neural network, what is Brain.js, and then we are going to have a hands-on activity on Brain.js, its advantages and usages. So what are neural networks? A neural network is a machine learning or artificial learning program that makes decision in a very manner similar to human brain by using processes that mimic the way the biological neurons work together to identify phenomena, weigh options, and arrive at conclusion. In a very simple language, I can say that they work just like our brain or the neural networks in a brain. So for the analogous, I have kept a very simple example to know the better whether a door is closed or not. So we will rotate a doorknob. If it's rotate, we will assign a weight 1 to it. If it's don't rotate, we will assign -1 to it. So if it's +1 at the end, we can say the door is open. If it's -1 at the end, we can say door is closed. So it's how just artificial neural network work. So in the below picture, we see that we want to convert x to the y. So we can use many calculations. We can multiply x with many things. We can add biases to the x to convert it to y. And that's how our ANN works or artificial neural network works. So what are types of neural networks? We have a feed-forward neural networks. There's very simplest type of neural network and they're well suited for classification tasks. RNN. RNN are able to learn from sequential data such as text or time series data, and they're often used for tasks such as natural language processing and machine translation. Then comes CNN. CNN are well suited for image recognition tasks. They are able to learn to identify features in the images such as edges and shapes. A very famous example is identify a cat and dog from image. Then comes LSTM. LSTM is a type of RNN only, and they are very particularly good at learning from long sequences of data, but with a short context only. So they are often used for tasks such as speech recognition and machine translation. And then comes Gen AI, that buzzing word, or generative adversarial networks. GANs are the type of neural network that can use to generate new data, such as images or text. And they're often used for tasks such as creating realistic synthetic images or generating new text. And the Brain.js is compatible of making all of the neural networks within itself. So this is how a neural networks looks like in a real life. There's a many inputs and there are many outputs, and they're connected by millions of the hidden layers and the tons of lines. And thus we have to build this neural network in JavaScript. But do we have to worry about it? Definitely not. Thus a Brain.js library comes to play. Brain.js is a JavaScript library used to create neural networks that is very simple to learn and very easy to implement as well. It can build various types of neural networks that we just also. Compatible with web browser and Node.js, Brain.js enables the development of machine learning application across all various platforms. Brain.js finds application in image recognition, sentiment analysis, time series prediction, and NLP. And also it's backed by active community of developers who contributes to development and offers supports and resources. Thus, we can see that Brain.js is a full, complete pack solution of bringing AI to the browser with the help of easy language that is JavaScript. So what we're building today? We are building a cloth forecaster or dress forecaster that will tell us what should we wear on a particular day. For example, it's a sunny day. We should be wearing sunglasses, shirt, and a denims. It's a windy day. We should have mask, wind cheater, and a jeans. Similarly, for rainy day, we should have an umbrella, a jacket, and a track pants. So let's start building it. So we can install with npm install Brain.js in Node.js, and we can use a script in the front end. And now the most important thing I like about Brain.js, it's independent from front end and back end. The front end engineer can use the browser itself to train the data and use the personalized and the recommendation from the AI in the UI itself. And thus it is not building a very expensive CI/CD pipeline to the browser itself or to the server itself, the increasing the cost and increasing the efforts of the developer. So we are going to build a feed forward neural network and it's going to have two inputs and multiple outputs, and it will build a classification model. So building neural network is as easy as writing new brain.neural network with a bunch of inputs. So what are the bunch of inputs? This is a hidden layer telling the number of hidden layers we have, and the magnitude at each index tells the number of hidden nodes we are going to have. Then comes the activation function. Activation function work on each node and tells what the output will going to what will be the output going to the another node. It's a ReLU sigmoid of binary function depending on the class type of neural network we are going to use. Then is the iteration, the number of iteration we want a neural network to train for. Then is the learning rate. Learning rate is same. Learning rate is like the how much fastly or how much slowly our neural network is going to learn. Too much fast makes it a very bad learner, and too much slow makes it a very slow learner. So we have to hyper tune between a good parameter, a good value to make it a learning very fast and effective as well. So binary thresh is applied at the output layer, and it used to convert the output to the binary. And the log true means it will console all the output that the neural network has just learned. So building data, obviously without any data we can't train a neural network. So we having a 0 means nothing, means a null day, and 1 means sunny day, 2 means rainy day, and 3 means windy day. So when it's sunny day we should wear glasses, shirt and loose denims. When it's rainy day we should have umbrella, jacket and track pants. And when it's windy day we should have mask, wind cheater and tight jeans. So that's how our data looks like. And keep a note, we have randomized data, means 0, 1, 1, 0, 1, 1, to give up to give a neural network give a network experience of having a randomized data and not giving biases to the position of the day. So we can see that for 0, 1, 1, 0, 1, 1, that is a sunny day. We have a glasses, shirt and denim. And for the last, we 0, 3, 3, 0 and 3, 3, we have a mask, wind cheater and jeans. So let's train the data, and it's simple as net.train with a bunch of parameters again. So iteration is same, the how many times the neural network will learn. The error thresh is the acceptable error percentage from the training data. The log period is how many times the logging will be out. The learning rate is same as I told you before. The callback is the periodic callback that can be triggered while training, and the callback period is the number of iterations through the training data between the callback calls, and the timeout is the number of maximum milliseconds we should have to cut off our training. So now we have built a neural network, and yes, it was that easy to build a neural network. So next time to test the training. So we can use the net.run, and we can have an input that is 0, 1, 0, 2, 0, 3. So let's test for sunny day. And for sunny day, we have an output like 91% for glasses, 89 for shirt, and 92% for denim. And we can see that is a very good output regarding the input we gave and the just 9 inputs we gave and the randomized data we gave to the neural network. So, but what for the day, for like windy, sunny, rainy, sunny, and so on. So let's see its forecasting now. So for the rainy and sunny day, we can see that our AI model is giving us the output like glasses should be wear with 17% and umbrella should be weared with 60% output. And similarly for shirt 17% and the jacket 72%, denim 17% and track pants 60%. So we can see that even if the data is not given to training a neural network, its forecasting is very good. So that's how Brain.JS help us to build a neural network with such good forecasting. But how do we improve now? We can increase the hidden layers. We can increase the hidden layers by 10, 20, and how much we want. We can change the activation function. It's again depend on the type of the neural network you're going to use. We can change the activation function in output layer. We can make it binary. We can make it non-binary, and so on. And we can increase the number of neurons. So increase the number of neurons also increases the computation power and increases the training as well. We have a weight in initialization. So if we want to have bias to some day, we can add the weight to that day. If we have obviously if we have a more data, the more the training will be good, and the similarly the forecasting will be good. And we can have a normalizing and scaling data, means that if we want to scale data from 0.1 to 0.3 to avoid any unfortunating biasing, we can have that. And thus last we can use different type of neural network for different tasks. For example, if I want to have a speech recognition, I can use LSTM here. Now what are the advantages or use cases? It's have a JavaScript integration so that Brain.js developers have the leverage of power of neural networks directly within JavaScript environment only. Ease of use, we just build a complex neural network with 4 slides only. And the cross platform compatibility is same as we can use front end and the back end independently from each other, and thus saving us a lot of money and efforts of developer. And flexibility in network configuration. Developers can easily customize the architecture of parameters of neural networks, like including the number of layers, neurons per layer, and training iteration as well. So it can be trained according to our need. So thus how we conclude the power of Brain.JS, and we can say that building neural network in a back end or front end was very much easy with the help of Brain.JS. So thus giving a product an AI advantage. So that's all for the video. I hope you liked it. See you next time. Bye bye.